హాయ్ మిత్రులారా, మనం ఈరోజు ఫిజిక్స్ గురించి ఒక 4 మాటలు నేర్చుకుందాం. ఫిజిక్స్ ఈజ్ వెరీ ఇంపార్టెంట్ సబ్జెక్ట్ ఇన్ ఆల్ other subjects. So physics is a branch of science which deals the physical properties of the nature and surroundings. So the physical properties means if you are take if you take length, breadth, and eye area and volume, specific density, and some of the physical properties of the object. So when we are studying these properties, we have to compulsory we have to know uh, the physical properties. First, how much length, how much its breadth, how much volume, how much it is specific gravity, how much it is uh, what is that relative density. So these are the some factors you should know compulsory. So physics is a branch of science which deals the natural phenomena like lightning, electricity, magnetism, sound. mm, some of the important topics in physics is mechanics, then mechanics and waves and oscillations and thermodynamics and optics, uh, electronics, electricity, and magnetism, magnetostatics, and solid state physics, nuclear physics, spectroscopy, and quantum physics. These are the main topics in physics. You should see every topic in detail. So, physics, the science is derived from the word scientia. Scientia means to know the object, to know the knowledge. Science is derived the word Latin word scientia. Scientia means to know or to acquire knowledge. Scientia means it is a acquiring knowledge. So we should gain more knowledge from our surroundings. Science, in the science, so many branches of physics is there. Particularly, we have to see the mechanics. In the mechanics, we should study the fundamental quantities and derived quantities. The fundamental quantities, main 7 properties are there. First one is length and mass and time and electricity, electrical current and luminous intensity and amount of substance and thermodynamic temperature. These are the 7 important fundamental quantities, and from these fundamental quantities we have to derive derived quantities. So the product of the mass and acceleration we have to get to force. So F is equal to ma, and the product of the pressure is equal to force per unit area, force by area, and the momentum is equal to the product of the mass and velocity, and uh, density is equal to mass per unit volume. So these are the some important derived quantities. So the fundamental quantities, they don't depend upon any another quantity. These are seven derived quantities are so many there. So if you see in the physics, first vectors and scalars. What do you mean by vector? Vector is a physical quantity which requires magnitude and velocity. If you take a cyclone is coming from north to south with 50 kilometers per hour. So in this case, we see the magnitude of the cyclone is 50 kilometers per hour, and the magnitude is 50 kilometers per hour, and direction is north to south. So we have seen these two factors in this case. So these are the examples for vectors. It requires magnitude and direction. So another quantity is scalar, which doesn't require any direction. So it has only magnitude, like 5 centimeters length of the uh, pencil or paper, 5 kilograms of the books. The mass of the book is 5 kilograms, like that. These are important quantities in physics. Next, Newton laws of motion. In the Newton laws of motion, we have seen so many laws in nature. First Newton laws of motion is Newton first law. The Newton first law is that every body continues in the state of rest or uniform motion unless an external force acts to change the position of the body. So if the body moves in a straight line, it will moves in straight line. If the body moves in a rotatory motion, it moves in rotatory motion only. If the body moves in a circular motion, it moves in circular motion only. So these are the important uh, terminals in physics. Mm, and also and also we have to see the different live the different phenomena. See, my physics say something. Physics is ours. Different phenomena. Welcome to the live chart. Remember to God learn more. Live chart. These are the live chart participants. Who are the participants? No participants are there. So, if your body in a rest position, it will remain in rest position only, unless an external force acts to change the position of the body. So, the Newton first law is the law which describes the law of inertia. Inertia means it is a inherent property of the object which doesn't require relative motion itself. And the body doesn't want to move by itself. So action force is caused to move from one position to another position. So these are the main factors in Newton first law. So to study the Newton first law, we have to study the inertia of law of inertia. So in the law of inertia requires inertia nothing but it resists the relative motion itself. So a body in a rest, it will remain in rest. If you see what is the type of inertia? First inertia is the motion. Inertia at the rest means the body at rest position అంటే suddenly if a body in a rest position, if suddenly the body moves, what happened? When you are sitting on the bus suddenly moved. What will happen? To overcome the inertia of the motion, we have to fill down forward. You have to fill down backward. It is the inertia motion. Inertia at rest means when your bus is moving on the road, suddenly the bus driver make brakes. What happened? He will fell down forward to overcome the rest of the inertia of the rest. And another third one is direction of the inertia. When bus is moving left side, to to overcome the inertia from the left side, it will held on the right side. So these are the three important factors of the inertia. Inertia is the rest, inertia is the motion, inertia is the direction. So this is the law of inertia. And also inertia is the another case. Newton's second law means it is a product of the mass and acceleration. So the rate of change of momentum is directly proportional to uh, the rate of momentum is directly proportional to net force applied on it. So we have to take one object at one place, that is mass m, and another acceleration is a. So first body is mass m, its acceleration is equal to the rate of change of velocity. So v2 minus v1 by t is equal to a. So d by dt of f is equal to d by dt of the force F is equal to ma. So m into d by dt of velocity is equal to m into a. So the rate of change of momentum. Momentum means mass into velocity. So what is that distance? Distance is a vector scalar quantity. It doesn't require any velocity, any direction. And displacement is a scalar. It compulsory requires length. Displacement is a vector. It requires magnitude and direction. And velocity. Velocity is a vector. Velocity is equal to displacement by time. The rate of change of momentum d by dt of mb is equal to force. The force F is equal to ma. It is a vector product. The momentum mass with velocity is vector product. Scalar product means it doesn't require any direction. So the rate of change of momentum is directly proportional to the net force applied on it. It is a second Newton's second law. And Newton's third law, everybody knows by applying force towards the earth. And if you throw a ball upward towards the upside, an equal and opposite in direction, the same amount of force will be coming towards down. So a body is coming upward and a body is coming downward. These are the two opposite and equal forces are acting on a different objects. So for every action there is equal to opposite reaction. F12 is equal minus F21. These are the Newton's three laws. These laws are very important. So some of examples are when you are throwing ball upward, the same ball will coming towards downward. And also when we are a fish is swimming in a swimming pool, what happened? On end it will throws the water backside. the tissue, the body moves forward. And also you have to see the rocket. When we are hitting the gases from a rocket, when you hit the fuel in a rocket, the large amount of forces will be coming outside. So to overcome that forces, gases, the body is moving, the rocket is moving upward. So in this case, same amount of forces are occurring in different objects. These are the important Newton laws of motion. Uh, Next, we have to see kinematics. In the kinematics, we have to discuss the physics without force. In dynamics, we have to study the objects with force. These are the some important factors in physics. Newton laws. Next important topic is relative density. Relative density. Relative density. Uh, Relative density or numeric density. Relative density or unit density class. These are the important phenomena in important phenomena in our physics. View feedback. So, friends, so we will see another topic, that is sound. Sound is a physical phenomena. Before that, we have to see the wave. Waves is nothing but a disturbance created in a medium. Either that medium is solid, liquid, or gas. Solid, liquid, or gas. Any medium. So if we create a disturbance like sound, like water. You have to take one tub of water, you throw a stone on surface of the water. A stone on surface of water. What happened? Ripples occurred. Ripples are created and generated from one object to another object. So we will see that what is that? What is the physical properties of the sound? But sound, you should see waves. Wave is a physical wave phenomena. So waves are generated in a medium. So if you take a sound wave, it is a air. In the air, the waves are created. If you take water, take a liquid, waves are created. Like you take strings, so waves are created. Known as non-mechanical waves. The mechanical waves are the waves which uh, doesn't require, which requires material medium. So another one is Planck waves. So in the transverse waves, the waves which the waves example is sound waves. So when we are sitting in a classroom, I am telling a lesson to the children. The children has to listen that words. So what is the phenomenon occurring between you and the children and teacher? So when I am talking in a class, the voice of the uh, air is in between you and me. So that air particles are there, air particles are there. When the particle of the medium means in the air particles are vibrate perpendicular to the formation of the wave, is known as lateral wave. Means in the lateral wave, some cases the waves are uh, compressed. Some waves, sometimes the waves rarefacted, rarefaction. So, so some waves are sometimes waves are waves are created. Sometimes the waves are compressed. Nothing but it is a compression. Sometimes the waves are moved from one of another. So that is rarefaction. The compressions or rarefactions occurred in one phenomena. This is nothing but lateral wave phenomena. Example is sound waves. Next to transverse waves. In the transverse waves, the particle of the medium vibrate perpendicular to the formation of the wave. In that wave, you have to take one rope. You uh, you have to take the rope in your hand and you have to attach one hand to the wall, and another side you have to attach with your hands. So when you are giving jerk to the thread, it will make some it is a in a curve way. So what happened? The waves are created in that string. So one upward part is there, one downward part is there. Upward part is known as a crust, and downward part is known as a trough. So crust and troughs are generated. In this phenomenon, the distance between crust and crust are trough and trough. You have to see the wavelength. Now, in other phenomena, the distance between compression and compression or rarefaction and rarefaction. You have to see wavelength. So these are the two types of waves in progressive waves. Another one is a stationary wave. The stationary wave is the wave which the progressive waves are the waves which are moving only in forward direction. So they never come back to backward. So forward means forward only progressive waves. Another one is stationary waves. So the waves are the waves which are moving in forward and also backward. These are the stationary waves. In the stationary waves, you have to see one curve is like this and another curve is like this. So it is a loops. We have to see the loops. Whenever the amplitude is maximum, in this case, it is a loop. We have to call it is a antinode. And whenever amplitude is minimum or zero, you have to see it is a node. And whenever in that low in that stationary phenomena, we have to see antinodes and the nodes. The distance between nodes and nodes are antinodes and antinodes. We have to see the wavelength. So basically, we have seen the physical what is that the definition and classification of the waves. Progressive waves and stationary waves. Progressive waves are two types. Stationary waves is only one. Next to non-mechanical waves. Starting time we have to define the waves are two types. One is mechanical and other non-mechanical. Non-mechanical waves are the waves which doesn't require any material medium. So these rays are coming from directly from space. In the space there is no medium like air. So the waves are coming from from outside directly to earth. So best example is uh, we have to see that electromagnetic spectrum. In the electromagnetic spectrum, first one is uh, what is that? Visible light. In the visible light, the wavelength range is 4,000 to 7,000 angstroms. Below 4,000 angstroms, it is a X-rays, gamma rays, and ultraviolet rays. So these are the wavelength is very low compared to visible light. The visible light wavelength range is 4,000 angstrom to 7,000 angstroms. In this case, we have to see the VIBGR, violet, indigo, blue, green, yellow, orange, red. These are the spectrum. In this case, in the spectrum, maximum wavelength is red, minimum wavelength is violet. So frequency is quite different. Wavelength frequency is equal to 1 by new 1 by and what is that? Frequency number of vibrations are made in 1 second. So whenever frequency is more, what happened? Wavelength is low. When wavelength is low, frequency is more. And the maximum wavelength is infrared rays, far infrared rays, and radio waves and microwaves. These are the waves which are more wavelength than visible light. Next, so these are the waves which are doesn't require any material medium. These waves are non-mechanical waves. These non-mechanical waves are the waves they are coming from space. So in that waves we have seen mechanical waves and non-mechanical waves. Another topic is that electricity and electronics. So what is that electronics? Electronics, the study of the electron. So basically, what is the atomic structure? You should see in the atomic structure. Before once upon a time, so many scientists, so many intellectuals have discovered that the atom is not indivisible. The atom is indivisible. Some period of time, what happened? So many members had discovered that atom also divisible. First, Kanadudu, he told that the universe is made up of atoms. Everywhere, atoms are there. Kanadudu. Next, uh, uh, Thomson. Thomson promoted that lemon watermelon model. What is that? In the watermelon model, the electrons are and electrons protons are melted. Electrons protons are arranged in a atom like lemon. The electrons are arranged in the lemon like grains, and so some period of time it came drawback. Next to Rutherford proposed what is planetary model. In the planetary model, the electrons are revolving around a nucleus. The protons are inside there. So electrons are revolving around the nucleus. The protons are inside there. So whenever the electrons revolving around the nucleus, what happened? The atom will lose its energy, and it collided to the nucleus. So the atom will be disappeared. To overcome that atom, it is not compulsory. So how can the atom will get energy? So it is a failure. Next, Niels Bohr. Niels Bohr proposed Bohr's model. In that Bohr's model, the station orbits are created. Whenever an atom is created or an atom electron is revolving around a nucleus in an atom, it doesn't lose energy. The energy, the atom will get energy from itself. It is a stationary orbits. So the electron always revolving around the nucleus in stationary levels. So these are named denoted by KLMN shells. We have seen. Next, when electron jumps from outer shell to inner shell, energy is released. If outer shell has energy, energy is equal to h nu. Inner shell is, if you take third shell, that is 3h nu. So third shell electron will jump into second shell electron, that is 2h nu. So h nu is equal to 3h nu minus 2h nu is equal to h nu. H is nothing but one constant, nothing but frequency. Okay, these are the important phenomena. Next, so many members came. Heisenberg and Schrodinger wave equation. Next, quantum mechanics. Uh, so many have proposed different types of atomic models. Hydrogen atom, atomic model. These are the some important terms we have seen in that atomic structure. Next, atomic number. The number of electrons or protons are present in a atom. In an atom, we have seen that it is a atomic number. Next, atomic mass number. The number of nucleons. In that nucleus, the total mass of the object present in one center part only. That is nucleus. Nucleus nothing but so subatomic particles are three. First one is neutron, proton, and electron. So the total mass of the atom present in only nucleus. Nucleus nothing but neutrons and protons. So the number of neutrons and protons is equal to atomic mass number. The number of protons or electrons is known as atomic number. So atomic neutron was discovered by Chadwick. Proton was discovered by Rutherford. And electron was discovered by Thomson. These are the some atomic particles. And we have to know the atomic numbers compulsory up to 30. And also we have to know the electronic configurations. These are the important topics in our daily today. We have seen in daily today life. And also we have seen different phenomena in our daily life phenomena, daily life examples. We if you know the physics perfectly means we should know the if you know the physics perfectly means you should know the applications of physics. So we have seen upper class academic standards. So what is the academic standard 1, academic standard 2, up to 7? So we have to apply, we have to appreciate daily lives, we have to understand the laws, we have to in our daily life, we have to appreciate the service of the scientists, and we have to describe, we have to differentiate the natural laws, how should it occur, what is the reason behind the nature, and we have to see the what is the how sun is rotating, how earth is rotating, what is the solar system, why should we miss, these laws. So in everyday life, we have to see different life phenomena in different sections. Next, sound wave. Another fundamental topic is electronic electricity. So the charges at test position, we have to see. We have seen that electrostatics, and we have to study that charges at test position. At the charges of their motion, we have to see that electricity, and also what is the potential. The potential is the amount of work is to be done to take a unit positive charge from one place to another place in a one place to another place in a field. And the potential difference. Potential difference means the amount of work is to be done. The difference between two potentials. The amount of work is to be done to take positive charge from one position to another position. And then the potential difference measured in volts. The resistance nothing but it opposes the relative motion. It is nothing but it measured in ohm. What is the Ohm's law? Ohm's law, the potential difference is directly proportional to current applied on it. So V is proportional to I. So V is equal to IR. So resistance R is equal to V by I. So resistance is equal to potential difference by current. The substance which obey Ohm's law, nothing but ohmic substances. The substance which doesn't allow Ohm's non-ohmic law, it is a non-ohmic law. These are some important topics in our physics basics topics. Next to mechanics. Mechanics. Next to electricity, electronics, all physics. Physics. Some basic class. Fundamental. Quantities. So once we have to remember all this, distance is a scalar. Displacement is a vector. Velocity is a vector. Momentum is a vector. Force is a vector. Total angular momentum is a vector quantity. What is the scalar? The quantity which doesn't depend upon its magnitude, its direction. Is a scalar. Example is like book, pen, pencil. These are the some quantities in physics. Next to equations of motions. Acceleration, the rate of change of velocity. The body moves from one point to another point. If the body moves in a straight line, so it requires some time. If the body moves in a curved path, it requires some time. So the maximum distance from one point to another point is known as displacement. If the body moves some distance in a manner, in a way, so the shortest distance nothing but displacement. So the displacement per time is equal to velocity. The change velocity time is equal to acceleration. So there is a link is there. Next, mechanics. Water phenomena. So, we will see next what are the important topics and we will discuss and we have to see that videos. Thank you. This is also. So physics is universal. So we have to apply the physical laws in the nature. Wherever you go, the physics never ends. Physics is a the universe has though as doesn't have any limit. Whatever the universe is there, in that same the physics also there is no limits. The physical laws are never ends. The physical laws has proved. The physics doesn't depend upon any another quantities. It is proved. Uh, it is applicable in the nature. It is easy to understand the natural laws. Physics is a very interesting and very um, good subject when we are understanding the nature in a systematic way. Then only we have to understand the physics very simple way. So if you think the nature is uh, very complex, means we cannot understand the physics. Our physics laws are in nature very simple, very easy. So you should interest the physics laws, the physical laws. Thank you. Thank you. Say bye. Next I will come another video.